Students, this video will explain you how would you perform Ohm's law experiment, and for that experiment you need to have all these apparatus for you. Number one is power supply or a battery. So this is the power supply, okay, and this is the variable power supply. We can use it for different volts, okay. So depending on the experiment we can work on specific voltages, but in this experiment we will be stick to 4 volt because we want to get I'll tell you explain what is the reason for getting just 4 volts only. Should be connected to the power supply on. It has a switch on it. Next you need to have an ammeter. This is the ammeter, and this ammeter is used to measure the current throughout the circuit, okay. And then you need to have a voltmeter. A voltmeter will help you to measure the voltage across any resistor. This is a type of fixed resistor and it has 2 terminals, and similarly we have seen this apparatus that is called variable resistor. We can slide it to vary the voltage or current across the circuit. First of all you need to do is just to look at your circuit diagram and try to prepare a circuit, set up a circuit based on the circuit diagram given to you. So look at this is a symbol for battery and this is a symbol for switch. So in this particular setup we have already given you a power supply with switch. So this power supply and switch, they are same, which is this one. So one terminal from power supply should go to ammeter, okay. Let's go for it. So we'll take the connecting wires, we're going to use it. So you connect to one of the terminal, either black or red, doesn't matter, and I'll tell you what is. You can easily fix it with the crocodile clips. Make sure the crocodile clip is connected to the inside the metal. Look at this one, inside the metal should be connected, and the other terminal should go to the ammeter. Now, ammeter has 3 terminals. One is black and 2 are red. This black one is a common terminal, always be connected, but these 2 red have different functions. When you look at on the meter, for the first one is giving you a maximum current of 1 ampere, and the second one will give you a maximum current of 5 ampere. So what you have to focus here, that you have to decide what range of ampere you are going to work with. So we are working on low currents. 5 ampere current is a huge amount of current. It can create a lot of heating effect. Overheating may damage our equipments. So we need to focus. We need to work on 1 ampere. So we need to have a connection with actually the common, which is black, and one with the 1 ampere current, right? So we connect it with the 1. Okay. You can connect directly like this. Connect like this, or you can loose the screw and make a connection exactly like this. Both ways is okay. Then a terminal from another terminal is going through the resistor. Take another wire, connect to another terminal of the ammeter and pass it through the resistor, and from the resistor it's going to the variable resistor here. So from the resistor here, another terminal of the resistor, it will go through the variable resistor. Make sure a variable resistor has 3 terminals, 1, 2 and 3. So we have to make sure that they have different function, but this rheostat we are working as a variable resistor. So we add one connection at the top here, other connection at the bottom from here. Okay, it's up to you whether you start from here or there, but just make sure that you have one top and one bottom. So I'll connect this terminal that is coming from variable resistor. You can put it here. Okay, make sure. And from the variable resistor is going back to the battery or power supply. So I take another wire, and you connect this to the other of a battery. Make sure we're doing all this work on. Okay, but we forgot voltmeter here. Voltmeter should be connected in parallel to that resistor. So this is your resistor, this is your voltmeter. We should work in a parallel connection here. So this, we need another lead, connect it through the resistor and give it to the common terminal. Right, need another lead, connect to the other terminal and give it to the low volt, again the same thing, low voltage supply. Okay, all set. Setup is there. Now you need to switch on the circuit and look at the two values here, because sometimes the connection may be wrong. So if the connection may be wrong, we can easily look at the voltmeter and ammeter and then look at it. Okay, let's go switch on. You can look at when I switch on the circuit, the current and the voltmeter, both readings are going to the negative direction. So that means you have done something wrong in the connection. If both of them are negative, you need to change the terminals of the battery. If one of them is wrong, you just need to change the terminal of these two. Right? If one is positive, one is negative, you just need to change the negative one. But in this case, both of them are negative. We need to change the direction of the battery. Make sure you do any change, make sure the circuit is stopped with the. Look at this, I just changed it. When I switch it on, something is positive coming to me and something is positive here as well. Okay, this is how here your practical starts. So look at the observation column here. Look at the observation column. On one you have voltage across the resistor and current through the resistor. Here we need to vary the voltage with the help of variable resistor and set it up with a value, and we need to fix the voltage using variable resistor and look at the current reading here. I'm going to go for, you need to have at least 5 readings because you're going to go for a graph on the next page here. Right, so let's start. Switch on the circuit. Current is something here. You know what I'm doing here? I have to slide it. The moment I slide, you see that variation in the voltage here. Now I'm sliding it. You can see. I'm sliding it, and once it is actually 1 volt, I stop here. You have to be on exactly on the top. Look at the camera now. If I move it here. If I look from that side, that means the wrong reading. If I look from that side, still a wrong reading. Your eye line of sight should be exactly perpendicular to the scale. That will give you avoid the parallax error. So you just need to fix it to the 1 ampere. Let's say we fix it to the 1 volt. Sorry, and we look at the current value. So we have to look at the upper scale, because we are connected to the 1 ampere terminal. When you look at this 0.2, that's right. So you look at it, this is 0.2, 0.4, this is 0.3. So every terminal is 0.2. So 0.2, 0.22, 0.24, 0.26, like this one. So you fix the voltage to 1 volt. You go to the ammeter and get the current. Okay, so one reading is 1 volt, 0.22 or 0.24 ampere. You further slide it. Whenever you slide the resistor, it will move to the specific value here. Now it's moving. So you fix it one, let's say this time is 1.4. The value is 1.4, and 1.4 voltage. What is the current? Current is changed to 0.3 exactly. So you write here 1.4 voltage and 3 ampere current. Similarly, you move further slider to get more range of the values. This time I will stop at 1.5, let's say. 1.5, and this time when I go to 1.5, current is changed accordingly, which is almost 0.36. So third reading is 1.5, 0.36. This is how you vary voltage and can record the current. Make sure if you are not reading anything, you switch off the circuit, because there is a source of error. If you keep allow the current to flow through it, it may create a heating effect, and that heating effect may damage our equipments here. So another sources of error: number one, reading error. Your eyesight should be perpendicular in both of the emitters. Number two, if you keep running the current, it may cause overheating, and it will be caused as a damaged equipment error here. Third error is actually the contact error. Look at the contacts I made here. They are not the 100% proper contact. And look at this one, it moved immediately. So the contact you made are not perfect contact. So you can say may have a third error, must be contact resistances. Right? Then you need to draw the graph. Okay? And then you complete it.